Hello, Java programmers. Let's talk about managing groups of things. In computer science and software development, we don't think about doing things once. We do things many, many times. We loop, we repeat processes over and over, and we also manage large sets of data. So it makes sense to be able to create collections or groupings or gatherings of similar things and manage them individually and also manage them as a group. We're going to focus on a fish, which is just my personal choice of something to manage, but this technology applies to any type of information that you might be programming about. I provided for you a source code file, fish.java, just to save us from a lot of typing. You can also download that. It's in the learning module. I am going to create a new project and then I'm going to drop in that fish file. I'm calling my project collection of fish. Now I need to tell Eclipse about this file, and this is a little bit hokey, but I'm going to create the file and then just overwrite the contents of it with what I provided for you. You don't have to do it that way. You can tell Eclipse that the file's out there on the disk somewhere, but this is just a little bit more straightforward, I think. I don't have to worry about file paths and where things are and if they're not in the workspace. I'm going to say new class and I'll call it fish, and I'll put it in the fish package, and then I'll immediately delete what's in there, retrieve off the slide that code that you can't even read. The only reason it's there is for you to copy it off the slide. If you have downloaded it from the learning module, that's fine too. Paste it in, and it doesn't look terrific, but it's there. And if you match the package name, you won't have an error on that line of code. But the indenting isn't that great. Now I can do a Control-Shift-F, remember, to automatically reformat a source code module in Eclipse. Control-Shift-F. And that does me a lot of help. Some things aren't perfect, such as when this line got extensively long in the toString. It broke it up into two lines, but not in a logical way. That's all right. Also, I want to point out that I left out many Java docs simply to keep the program smaller so I don't have to scroll up and down as much and make you dizzy. But if you delivered something like this, you would Java doc all of the methods and the class. This class is modeling a fish. It's out there swimming around. It's having a great day. And it's going to get caught. I guess that would make it not such a great day. Fish probably don't want to be caught. They generally put up a fight. All right, we have our project. We have pasted in our donor code. Now let's think about a real world scenario. There are many, many more than one fish in the East Fork Lake, even though it might not seem like it because I never catch any. But if I want to track a whole bunch of fish, which I probably would, I've got a couple options. One option is to just declare thousands or millions of fish objects individually, and that would rapidly become a disaster. Let's look at that just as a quick illustration of the disaster. I'm going to create a new package for my main, and inside that package I'll put my main class. Now we have an entry point for our code, which is great. I'll omit the documentation here simply for the sake of time, but remember there would be some documentation in this main. And I will say that I need, let's say I need one fish, and that's no problem. I can say fish bass equals new fish. With me, and I hope you are, because the main class is in a different package from the fish class. Therefore, they don't know about each other. And you have to tell Eclipse that it's okay. Import the fish class from the fish package into the main class. And that makes that error go away. The other error is because there is no default constructor in my fish class. I can't create a fish the way I'm trying to do it. I can't instantiate using the default constructor. Remember, this terminology is very important. So when I say there is no default constructor, make sure you know what that means. Make sure you know that when you create a class, you automatically get a constructor that takes no arguments. It doesn't appear in your code, but it is the default constructor. However, if you create a constructor in a class, you automatically override and remove the default constructor. Looking at my fish class, I see that I have provided an explicit constructor that takes 3 arguments: the species of fish, the weight of the fish, and the date it was caught. Also a copy constructor, which we'll talk about in a bit. So I can't, in my main, instantiate a fish with what used to be a default constructor but is no longer available in that class anymore. Very important terminology. We're throwing around all kinds of buzzwords. If you have to stop the tape and look up the definition of a term, by all means you should do that, because it's crucial that we can all talk the same language. In order to get this to work, I have 2 options. Eclipse thinks I have 5. One option is to tell Eclipse to create a constructor called fish with no arguments. In other words, restore that default constructor in the fish class. That's a bad idea because that changes the design of the fish class. And unless I'm the owner of that class and I know what I'm doing, I shouldn't go adding default constructors for no good reason. Another option is that I can use one of the other 2 existing constructors. And the one I want to use is the one that takes the string, the double, and the date. The copy constructor doesn't do me any good. That's the first quick fix it's suggesting, because I don't have anything to copy right now. I'm going to go ahead and take the second fix, but I'm going to type those arguments in, because if I let Eclipse do it, watch, it's just a big mess. Eclipse doesn't know what that data should be, therefore it just defaults it to the lowest common denominator, which is null for a string, 0 for a double, and null for a date object, and that's not good. Let's put something in there. Let's make the species bass. Let's make the weight 10.5 pounds. It's a biggin. Let's make the date it was caught 2022-02-114. I went fishing on Valentine's Day. And now what is it unhappy about? Now it says the constructor called fish that takes a string, a double, and another string is undefined. I still don't have anything that matches this attempt to call a constructor. I don't have a constructor that takes a string, a double, and another string. I need to go back and look more closely at my fish class, and I see that the third argument is a date. It's not a string. It's a date type, and that's new to us. Since we haven't seen that before, let's do a little bit of investigation. And we need to figure out how to work with this thing called a date. If I hover over it, it says it is from java.util.date. If I look up at the top of the program, I see there's an import for java.util.date. So it's bringing in the definition of that class. And that's fine, but I still need to know how to work with it. I noticed a comment here that I left for you. There are many, many date classes. Almost everything we do is time-based. Therefore, as people develop classes over time, they create many representations of dates and times. So if you don't include the right date class, you are going to cause yourself all kinds of grief. This is a standard, so to speak, java.util.date. It's part of the Java standard library. Therefore, it's okay to use, and it's one that we should look at with great interest. But there are many other ones out there too. Just a word of warning, be careful. Let's dig into that by going to our search engine. And let's say in quotes java.util.date. And I put quotes around it because it's got dots in it, which tend to be separators in a URL, and they just make me nervous. They're probably okay to leave them out, but sometimes I quote things. There's a couple different hits. The format, this looks interesting. Example, maybe it'll tell me something about how to create a date. Lots of different choices here. Let's just take the first one. What I really want to know is how do I create a date object that I can pass to that constructor. So hopefully there's a date constructor right there. There's one. Creates a date object representing the current date and time. So all I have to do then is invoke that constructor to create an instance of the date class, and that'll at least get me up and running. It might not be the right date, but it'll work. And then there's another example of a date constructor where I can pass in the number of milliseconds since January 1st, 1970, which is kind of a special day in programming. A lot of date classes use January 1st, 1970 as the beginning of time. Nothing happened before that. And if I knew how many milliseconds that was all the way to today, I could put that number in there. But that's a little problematic to work with, as you might imagine. So I'm going to use just the default constructor. Back in my main, to make this error go away, I'll just put new date object. And you can see that it's still not happy, because even though I've talked a good game and I've shown you the date class, I demonstrated that the fish class knows about it. The main class still doesn't know about it. In order to use it here, I'm going to have to do the same import statement that I did in the fish class. Here's an illustration of that warning I gave you a few minutes ago about the proliferation of date classes and the care you should take. The very first fix that Eclipse wants to offer us is to import java.sql.date. There's a date class that's part of the framework for manipulating SQL files, SQL Server files, MySQL, Oracle. So If you bring in that date, you can probably get it to work. It's probably a reasonable representation of dates and times, but it's not as standard and not as well understood by as many people as java.util.date. And this is a good example of Eclipse leading you astray. I mean, the Eclipse made an educated guess. You referenced something called date. It found two instances of a date class in two different packages, but it listed the less popular one first. I'm going to pick java.util.date. That adds the import statement to the main, the same import statement that's in fish. They both have to import that class. The error goes away, and now I have a fish. Circling back to why I even started doing this in the first place, my point was that I can manage one thing, but as it says in slide 2, I rarely want to manage one thing. I want to manage many, many hundreds or thousands of millions of things. And the point I was making in that main when I started down this road was I could very easily, at least to start out with very easily, create a whole bunch of classes, a whole bunch of objects to manage all of these basses. I guess bass is the plural of bass. And as my program grew and became more capable, I would add more bass objects. And perhaps I caught another kind of fish that might be a catfish. And so on and so on. But that's a real headache. Now these are all discrete, unrelated variables, and managing them would be a headache because I can't touch all of them at the same time or step through all of them in some kind of iterative procedure like a loop. Therefore, this is a bad idea. And hopefully I've talked you out of it already. Hopefully you realize that creating thousands and thousands of objects in a program just creates a headache for everybody involved and will probably make you want to become an Amish farmer or to be the coach of the Dolphins. So what we need to do then is look at a different strategy. And our strategy could be to build up a data structure, which we generically refer to as a collection. And that data structure can manage all of the objects as a group. We've already studied array lists and arrays, and you saw how convenient those are for managing sets of homogeneous data. There's another structure called the hash map, which we'll get to later, that might be interesting for this application. But I've decided we're going to use an array list because we understand it and it works for our purposes. So we'll go back and create that data structure. But we're going to take a step back and realize the data structure needs to be managed. Creating an array list of fish is great, but I can't just turn anybody loose on that array list because who knows what they'll do with it. Delete it, erase it, add silly things to it. What I need then is a way to manage that data structure. And the strategy is to take it away from you, to take it away from the developers who might use it, and wrap a class around it. This is something called a design pattern. And I'm referencing a book here called Design Patterns, written by 4 very famous people in the software engineering field. And I highly recommend that you get a hold of this if this is your career path. If you plan to be a developer, get a design patterns book and start reading it, because this is also part of the language we speak. And if I tell you to implement a facade design pattern, then you'll have some idea what I'm talking about. And if I tell you to implement a facade design pattern and you've never heard of it, then you're going to just nod your head blankly, and as soon as I'm out of the room, go diving for the internet to find out what a facade is. There are a lot of design patterns. They overlap. There's no 100% agreement on what exactly comprises a design pattern. Some of them are a little bit vague intentionally, but they're worth looking at. This is not the kind of book that you read at halftime of a Dolphins game. This is the kind of book you use as a reference when you need it. So it's not a novel, it's not entertainment, and it's not meant to be read from front to back unless you're really, really weird like I am. But it's an excellent resource for you. And there's a million other design pattern books, but this is the one I like. That's the end of the slideshow. Let's dig into our code. And remember, I'm just going to back up to slide 5 again. We're going to take this data structure, which manages a large number of objects, in our case fish objects, and we will build a class around it to give us control over what happens to that data structure. I am going to call this a facade. You can look that up if you like. This definition that I just found here for you says a facade is a class that provides a simple interface to a complex subsystem which contains lots of moving parts. What we're doing could also be construed as a wrapper, W-R-A-P-P-E-R, because we're wrapping some code around an array list. But that could be argued too to be incorrect because we're doing more than just wrapping code around the array list. We're adding functionality to it. So as I said, there's always a little bit of debate over what comprises a specific design pattern, but there are general rules to follow, and learning to talk the language of design patterns will help you immensely. I'm going to delete all but one of my fish, just leaving me with bass. I like to have something in my main. This makes me feel good. We also mentioned that we are going to take our data structure and put it into a separate class. It's not going into fish. It's not going into main. It doesn't make sense for it to go either place. It doesn't make sense for it to go into main. I'll put it in here, but we'll take it out almost immediately. Array, list, fish, fishes equal new array list fish. And you realize that it doesn't know what an array list is. Main.java has no clue what the array list class is. Therefore, you have to import another class definition, java.util.arraylist. Notice that there are now 2 import statements in this program. Import statements will grow and grow and grow. There will be plenty of those in most of the code that you write. You can collapse that down, and it's less scrolling to do. Eclipse just rolls that up into one line of code, and it labels it with a little plus sign showing you that there's more than that behind it. And that's a good thing to do because you don't really need to look at the import statements. They don't need to be debugged. Once you put them in there and you've done it correctly, they don't have to be changed. So collapsing them into one line of code is very convenient and easy and worthwhile. Once I've provided the definition for the ArrayList class, I am able to build, declare, and instantiate an instance of the ArrayList class. Remember, the ArrayList class is parameterized. We could put a comment here. This is a parameterized class. Probably spelled it wrong. Meaning that when you instantiate an array list, you have to tell Java, what kind of things will be in that array. In this case, the parameter is fish. We're saying we're creating a collection of fish objects. We have to do it twice. I think there's a syntactical way to get around doing it twice, but I usually just do it twice. It shows up in the declaration part of the statement and shows up in the instantiation part of the statement. But I don't want that in my main. I promised you that was going to go away, and the reason it's going to go away is because, remember, our goal here is to do two things, is to model a fish, which we've done wonderfully. I gave you that code. The second goal is to model a collection of fish. I'll say that again. We're doing two things here. Model a fish and model a collection of fish. And by putting that collection of fish in the main, I've ruined all my hard work because now you have to use my main in order to get anything to happen. And you know you're not going to use my main. The purpose of a main is just to provide an entry point into all the other wonderful classes that are going to run. And it's 99.9% certain that someone else is going to be writing that main, not you. Therefore, it shouldn't be in the main. Well, what should it go into the fish class? If I cut this thing out of the main and I go back to fish, should it be in the fish class? The fish class models this thing, a fish swimming at East Fork Lake. It does not model a collection of fish. To put this in here is just wrong because it's a violation of what the model is supposed to be. All of a sudden, we've got a whole bunch of fish inside a model of what is supposed to be one fish. It also looks a little bit odd because it's referencing itself. The collection array list fish references fish, but that is also inside of fish, and that sometimes that's a little awkward, and when you sense that awkwardness, you're probably looking at something you have to fix. That's going to go away. We've demonstrated that it should not go in the main. We've demonstrated that it should not go in fish. It's going to have to go somewhere else. Let's make a new class. New class. I'm going to put this in the fish package. And I'm going to call it fishes. I think in some languages, fishes is the plural of fish. I don't know what, maybe it's a cultural thing, but I need a plural for the word fish, and I can't use the word fish as the plural for fish because we're not writing English, we're writing Java. And I will go with fishes. Inside fishes, let's give this thing a little Java doc. Let's say model a collection of fish objects. There we go. We have separated the ability to manage a collection of things from the definition of the thing, which is very good. And the first thing we'll put in here is our array list. At this point, it's a wrapper, W-R-A-P-P-E-R. If you're looking at the design pattern. Also, I might make the argument that it's a facade. That's why I showed you facade earlier. But we're going to add functionality to this data structure. And we're also going to provide an interface to this data structure. I'm not going to let you go directly at my collection of fish. You have to go through methods that I provide. Since this variable is private, fishes, no one can see it outside of this class. It is limited in scope to the fishes class. If I want you to be able to add a fish, to the collection, delete a fish, search for a fish, reinitialize the collection. I have to provide ways to do those things. And that's more work, but that's good because I get to decide how you access my collection. Maybe I don't want you to add duplicate fish. Maybe I don't want you to add too many fish. All the things that could be restrictive or important in the concept of a collection of fish, I get to control. Our first consideration is the constructor of the fishes class. What should the constructor do when I create an instance of fishes? And you'll get experience doing this and it will become evident to you as you go along. But I'll tell you right now, the first thing it's going to need to do is instantiate our fishes collection. We can't do that here. This is not going to fly. So we need to take this instantiation out of here. We want more control than that. Let's write the constructor. Fishes, whoops, open close paren. There's our constructor. And inside the constructor, let's instantiate. That is still the default constructor because it has no arguments, but we overrode the default version of the default constructor and we added a line of code that instantiates our array list. So whenever somebody creates an instance of fishes, we will automatically create the array list for them that will manage their fish. So right away I've relieved from you the burden of having to understand what the collection is going to look like. I've abstracted that away. Go back to the main, and in the main let's instantiate fishes. When that constructor fires, it's going to instantiate the array list to keep track of all the fishes. And we need to fix the import problem. It doesn't know what fishes is. That's easy enough to do. Import fishes. Another line gets added to our collection of imports. We now have 4. We've done very little work and we've already got 4 imports. And I think I messed up when I created the fishes constructor. It needs to be public. There. Now you don't have to worry about that anymore. If you're using the classes that I provided in the fish package, when you instantiate a fishes collection, you automatically get the array list behind the scenes. And that's called abstraction. I've taken away from you the requirement to understand how to create that collection. I've also taken away from you the requirement to even know there's a collection. You don't even know it's there. All you know is that you created a fishes object and it's going to manage a whole bunch of fish. Nothing else matters to you. It gets even better if next year I realize that the array list was a bad choice. All I have to do is rewrite fishes. I don't have to rewrite your code that uses fishes. I might decide to use a hash map or maybe just a regular array, who knows. But I don't have to bother you with that. I just go in and modify everything in the fishes class, and then your main class is blissfully ignorant and continues to work if I do it right. So that's the first thing I want to do in fishes. And then I stop and think, What is important to people who are going to be using my collection? What should it do? Well, it should instantiate, which I did. And the next thing you probably want to do is add a fish, right? You probably want to have some kind of method in the fishes class that you can call to add a fish to that collection. And keep in mind, you don't know anything about that collection. You don't know what it's called. You don't know the data type of it. You just know that I am managing it for you because I wrote this class. So let's write a method called add. And I'm not going to say add fish. I'm just going to say add because we know already from the Java doc in line 6 this class is modeling a collection of fish objects. So I don't have to call it add fish. I can. I mean, I'm not saying you shouldn't, but I don't think that I have to do that. Just call it add. I will expect you to pass me a fish. Whoops, needs to be void, sorry. And then I'm going to add that to my collection. Fishes.add paren fish. I'm invoking the add method of the array list. But you don't know that. All you know is that you're calling my add in the fishes class, and then I'm doing all the heavy lifting for you. Again, abstracting away details that you don't need to know about. If you go back to the main, we can add our bass. Fishes dot add bass. Now our collection has one fish in it. We don't know how it happened. We don't know what the mechanism's going on behind the scenes. We just called this add method and magically it got done for us. That's good. We can add as many fish as we want until we run out of memory. The next thing we definitely want to do with fishes is let people iterate over the list of fishes. And that sounds really hard. And I'll give you an example of that in the main because you're going to find, it will become obvious to you very quickly, that you need to do some operation against each fish in the collection. Print it, search it, edit it, average them together, add them up, something. That requires you to touch every fish. Now you don't know how many there are. In this case, so far, there's only one. But there could be 1,000. And anytime you see that you're going to have repeated code operating on a set of objects, then you think about a loop, right? Well, this is an opportunity for an enhanced for loop. And it might look like this, and this is going to fail, but we'll fix it. For fish f colon fishes, an enhanced for loop. Not enhanced, enhanced. And that says that every time we go through the loop, the next object in the fishes collection is going to be put into F, and we can operate on that F and do things with it. So the enhanced for loop is very adaptable or very useful when it comes to dealing with collections of things. The problem here, and we've created this problem on our own, the problem here is that fishes, strictly speaking, is not a collection. It is a class that has a collection inside of it, but it's not a collection itself. And that's why we get this error. The error says can only iterate over an array or an instance of java.lang.iterable. And I'll say that again. The problem here is that fishes is not an array list or a collection of any kind. Fishes is a class that contains an array list. So we have a problem. This is syntactically incorrect, but because we know how to program to the interface, we can make this work. This error message could be a little misleading. You see the word instance there in the error message. Now, instance might make you think that you need an object, right? Because when you think class, you instantiate a class, you get an instance of a class that's an object. Well, what you really need is an instance of something that implements java.lang.iterable, but because, and here we go, get ready, java.lang.iterable is an interface. How about that? Java.lang.iterable is an interface. Therefore, any class that implements that interface can be used in this syntax. So exciting. All we need to do is make our class fishes implement that interface, and we can use our class in an enhanced for loop. And that's probably scary. Well, what's in the iterable interface? Are there like 10 methods I have to write? Are there all kinds of classes and functions and methods, and do I have to stand on my head? No, you don't. Go back to fishes and add implements java.lang.iterable. And I got so excited I spelled it wrong. Capital I. Java.lang.iterable. Iterable with the capital I. The error now is in the class definition. You can see the underline, the red squiggle shifted over to fishes. And the error is that, yeah, you're trying to implement that interface, but you didn't do it. You lied. The type fishes must implement the inherited abstract method iterable.iterator. That's all you got to do. Okay, that sounds pretty scary. I don't know what iterable.iterator is. I've never heard of that in my life. But I'm going to let Eclipse fix this one. Add unimplemented methods. And Eclipse will make a first cut at writing those methods for you. And this is a case where that's a good fix. That's a good start for you. And there it is. It wrote a method called iterator, lowercase I, that returns something called an iterator, capital I. And we don't need this to do because we're going to fix it right now. All you need to do is, instead of returning null, return the iterator from the fishes array list. That's all you need to do. I had a little glitch there. I'm back with you now. I'll show you what I just typed in case you missed it. I returned the iterator that belongs to the array list. The array list is a private member of this class, and it knows how to let people iterate over it. So it knows the secret to iteration. All we have to do is pass the secret to iteration as part of our return statement. Now let's see how that looks in the main. We're getting to the point now where we need to be a little more conscientious about saving things, because a lot of errors that you're going to see pop up are a result of files not being saved and Eclipse not picking up changes between files. Look at my tabs, fish.java, main.java, fishes.java. All of those have stars next to the names. That means they haven't been saved since the last change. So if we have an error, like the one I have in the main in line 15, it's probably because I just haven't saved the changes that I made. I'm going to click the Save All button. Okay. And the error still didn't go away, but that's all right. It's different now. It's not the same error anymore. What the error is now is that it found the iterator, but it just doesn't like the way it's written. And we can fix this too, no problem. But remember to hit that Save All button periodically because it will make some errors go away. Now, the error says type mismatch cannot convert from element type object to fish. Okay, I can show you how to fix that. You need to go back over here and tell the method that it is returning an iterator over a fish. That should make the main happy if I hit Save All. And it didn't. The error changed to change type of F to fish. Well, F is a fish, so I'm a little confused. Everything is saved, and it wants me to change F to fish, but I have F declared as a fish. Pausing the video. I'm back. I found my mistake. Manages the collection. There is a warning, and I harp on everybody about paying attention to warnings. I didn't pay attention to it. I need to parameterize this. So now I'm saying that fishes implements an instance of the iterable interface that works with fish objects. I parameterized that interface. That should make the main happy now, and it does. That error goes away. That was a very cryptic error message that even when you took the fix didn't solve the problem. Very annoying. But it was my fault for not heeding the warning. Now we have in the main a technique for iterating over our entire collection of fishes. Even though that collection is wrapped inside of a class, we can still access it. So that's really good. And we should probably make this main do something. So system.out.println f.toString. Whoops. It only has one fish in it now. Let's add another fish above the for loop. Above that enhanced for loop. Fishes.add new fish. And we'll use the constructor again. Catfish. It weighs 20 pounds. And I caught it today because I'm lazy about the date. Now there are two fish in the collection of fishes. When I run the iterator in line 16, it will circle through the enhanced for loop and print out the information for each fish. And I got an error. Unresolved compilation problem cannot convert from object to fish. In the main line 15. All right. In the interest of expediency, let's just do it the same way we did. Fish. Catfish equals new fish. Da, 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 da. And then fishes.add catfish. See if that works. That worked, yay. You don't need to watch me fix that error. I'll just do it a different way. We added 2 elements to the fish collection, which we call fishes. And then we used an enhanced for loop to step through each element in that collection. But the cool thing is the collection is wrapped inside of a class. We don't have direct access to it. We can only use the methods provided by that class. The next thing we'll do is take a step back and examine our fishes class and talk about things that we might want to add to it. Remember that this fishes class models a collection of fish objects. It does not model individual fish. The only things that should go in here are features and behavior that are specific to the collection itself, not what is in the collection. One thing that people are going to want to know about their collection of fishes is how many fishes are in it. As it is right now, I provided a way to add a fish. I gave it an add method. I provided a way to iterate over the collection of fish by returning the iterator from the array list. I still don't have a way of determining how many fish I have, and that's something that people would want to know when they use this class. So let's add at the bottom public int length. How about that? And let's just return. We already have that available to us inside of this class, and all we have to do is just make it available outside of the class. Fishes dot, and my help is just a mess right now. All kinds of weird things pop up when I hit that dot. I'm not sure why. But fishes is an array list. So there's a property of an array list that tells you how many elements are in it at that moment in time. And I'm going to go back to Google because let's just say that you're following along with me and your help is broken too. So I'll say Java array list length. And it says array list doesn't have a length method. The size method provides the number of objects. So that's what I want. So I can say return fishes dot size. And you can see size isn't even coming up. I don't know why, but it does exist. We know it's there. And that's what I can return. This is a solution. If you think about it critically, it's not a good solution because we've changed the name of something that everyone was already familiar with. Everybody already knew that if they used an array list, they used the size method, but all of a sudden now we've changed it to length. Therefore, I'm going to change this to size so they both match. And that just helps all your developers who are using this work. So we can say system.out.println fishes dot size, and again it's just not coming up, plus elements in the collection. Let's see what we get. Hopefully we'll get 2, correct? 2 elements in the collection. I could change this to fish. 2 fishes, 2 fishies, 2 fish, I don't know. 2 fishes. All right, we've added another little snippet of functionality to our fishes class. We're modeling things that a collection would want to model. We don't care about specific fish. We might want to at some point start caring about specific fish, but only from the perspective of whether they're duplicates. So it's still relative to the entire collection, not a specific fish. The next thing I'd like to discuss is a nuance, but an extremely important nuance. We have a data hiding issue in this program. I'm going to illustrate it to you first, and then I'm going to show you how to fix it. In the main, we created a fish called bass, and that's great. No problem there. We added bass to the collection in the fishes class, and that's great. But we violated data hiding rules in the way that the fishes class stored that bass. The fishes class only stored a reference to the bass object. It didn't store a new copy of it. Now, the problem I have is that I still have access to bass from inside the main, and fishes thinks that it has the only access to bass in that array list. So there's a huge issue there, because if I decide later to do something to bass, change the weight of it, clear it, use it for another purpose in my program, then that's going to affect what is stored in the fishes collection in the other class. The data ain't hidden no more. And let me show you. Let's do bass dot set weight minus 100. Is there no set weight in fish? Oh, set weight in pounds. I'm sorry. Set weight in pounds. We're doing that on purpose. Intentionally change a value in the bass object. Okay? I'm in the main. This is perfectly reasonable for me to do. I mean, that bass object belongs to me. I declared it. I initialized it. It's in my main method. So I'm not doing anything wrong. I may have decided for whatever reason to reuse that variable or edit that variable. Now watch what happens. I am going to print the contents again of what's in the fishes class. I'm accessing the collection. And you'll have to study the output. In the first loop that I wrote a few minutes ago, I printed out the bass and it weighed 10.5. Remember, this is coming from the method, from the class that's storing the fish, okay? This is from the class that's modeling the fish collection. It thinks the bass weighed 10.5 pounds, which is correct. But then when I loop through that collection again, it now thinks the bass weighs negative 100 pounds. So by changing the value in the main, I affected a value that the class had stored as well. And the reason for that is because we really didn't pass the entire bass object to the add method in line 14. We just pass what's called a reference to that object. That's essentially the memory address for that object. You can think of it that way, but don't say that on Reddit or Stack Overflow or you'll get killed. But by passing a reference then, when we stored that in the fishes add method, we just stored a reference. That means the main and the fishes classes shared a reference to the same fish object. And that's bad news because now what is supposed to be a private array list in the fishes class now shares some data with the main class. We violated data hiding rules. And I'm going to put that right here. I'll put a comment in here. Violates OOP data hiding rules. We are storing a reference given to us by the calling method, whatever that is. Whoever calls this add method in fishes sent us a reference to fish, sent us the memory address of fish, and we made a copy of that memory address and just stored it away in our array list. So we had a problem there. That's not good. And this error may not surface for a long, long time, because you may never do what I did in the main. You may never go back and assign a new value to a property of one of these objects. You may use this thing in a harmless way for years and years, so then you might make a modification and boom, everything stops working. And it's hard to track down because the error is caused in this main method, but the error manifests in the fishes method where it manages that array list. And this will drive you nuts. The solution then is a friend that you didn't know you had, and that is the copy constructor. Here's one reason why we write a copy constructor. So we're going to go fishes dot add new fish open paren fish. What this does is this uses the fish copy constructor to create an entirely new object. It copies the data out of the original fish that was given to us in line 20, and it makes a brand new fish. That way we're the only ones that have the reference to that fish. Does this use more memory? Yes. Does this take longer? Yes, but that's life. If you want it to be robust, this is the way you have to do it. If you look at the copy constructor, it just calls the set methods on all of the fish properties. So you're taking the current object, whatever that is, and you're taking whatever was passed into the constructor and using that as the source for all the new data. If you want to think about it a different way, maybe it might be more comfortable to see this in front of it. It's the same either way, but sometimes the this pointer is more explicit, and that reminds you that you're dealing with the current object, whatever it is. There's the reason, or one reason, why we write a copy constructor. We've avoided violating that data hiding rule. We've avoided the possibility of some very, very difficult errors down the road. Let's sum up what we've discussed. We have a wonderful model of a fish. It is one fish. It is information specific to one fish. We realize that we need to control or manage or program many, many fishes. Therefore, we create another class that models a collection of fishes. The collection at this point, the way I wrote it, doesn't know anything about fish. It doesn't know what their properties are. doesn't know what methods they provide except for the copy constructor. But it does know about how to manage a collection. And we decided that our collection would be an array list because that's something we know about and that it works. We decided that this collection model would provide programmers with the opportunity to iterate. Therefore, what we did was implement java.lang.iterable, a well understood interface, and it's also a parameterized interface, so we had to tell Eclipse and Java that uh, our implementation of that interface would be dealing with fish objects. And then we provided a way to add fish to our collection by writing an add method. In the add method, we realized there was data hiding problems because we were storing references instead of creating brand new objects from those references. Therefore, we used the copy constructor to clone the object that was referenced, that was sent to us, into a brand new object. And that way, we're the only one that has that reference. Nobody can go behind our backs to access elements in our collection. And they will. I promise you they will. Finally, we wrote a main that demonstrated how to instantiate the collection manager, which we called fishes. After instantiating the collection manager, collection object, we added elements to the collection, and then we printed out the length of the collection, and then we demonstrated that there was a data hiding problem by changing a value of a local object and having it affect something hidden in the fishes class. And I guess I didn't finish the thought here, did I? I need to run this again to show you that that minus 100 goes away. I didn't do that. So this output you're looking at here is before I fixed the data hiding problem. You can see that the weight went from 10.5 to minus 100. And if I run it after fixing the data hiding problem, it remains 10.5, even though I changed it to minus 100 on our bass object. Hope that was interesting and helpful. Experiment, try things, watch videos. This is really important object-oriented stuff. Remember, it applies across the board to OOP languages. All the terminology we use, all the concepts, they differ in syntax. When you get to C#, they differ in syntax if you run C++, but most of the concepts are the same. Thanks for watching. Bye-bye.